Okay, hey guys. So we're going to move on to the next unit, which is systems of equations. But the first part I usually do is graphing, and I posted this exercise. So basically, what I have you do is I have you graph these lines. I took a picture and posted it. I have you graph these lines by hand, and then I ask you a couple of questions. Whether you've done this before, you've sat in a class, you're not sure. But since we don't have time, we're running out. We don't have that much time. I'm going to cut that out. But let me know. You know, we'll talk about it another time. So what I want to talk about today is the new unit, which is systems of equations. So let's take some notes. So the aim is system of equations. Okay. And so the first thing I want to talk about is what is a solution? So a solution. What exactly does that mean when you say, what's the solution? Well, it's a value or values we can put in place of a variable, that makes the equation true. That makes the equation true, right? So, for example, I want you to tell me if the following are solutions. So, question number 1. If x equals 6, then x plus 5 equals 9. Is this a solution to this equation? And you would say, no, because 6 plus 5 does not equal 9, right? So x equals 6 is not a solution. Oh, my pen's running out. Here we go. Okay, how about this one? Question number 2. If x equals 4, then x plus 5 equals 9. And some of you are like, Mr. Riley, this is silly, but this is the idea of a solution. That if I take this 4 and substitute for x, I get a true statement. And you're like, yes, 4 plus 5 equals 9. Therefore, 4 is a solution. Okay. Now, we're going to use, you've been doing this over the years, whether it's algebraic techniques, but the idea is you're coming up with something, a number that makes it true. So there's special equations. A couple of things we should need to go over. Special equations. I'm running out of ink. Let's see if this pen works. The first thing is called an identity. Identities are important because they allow you to replace one expression with another expression. So, for example, 2 times x plus 3 equals 2x plus 6. So you look at this and you're like, okay, I can solve this. And you begin to solve it, and what you notice is that you end up with, 0 equals 0. So what does that mean? Well, that means that this is always true for every single x. Therefore, this is always true for any x. Sorry. For any x. And you can see, right? So for example, if I put 1 in here, 1 plus 3 is 4, and 4 times 2 is 8, and then 2 times 1 is 2, plus 6 is also 8. So it's always going to be true. Sometimes, though, and we're really not going to see it in here, sometimes you have equations that are never true. Equations equations that are never true. Can you see that out there? Yeah, they're never true. They're called inconsistent. Inconsistent. An example is, for example, x plus 3 equals x plus 4. No matter what I do, I can never get this to be true. And you would see this algebraically. Is this on? Yeah, you see this algebraically. If you solve it, it would be like 0 equals 1. So we know that's false. So if you get here, not in this class, you have, it's inconsistent, never going to have a solution. Okay, so a system of equations is a set of two or more equations with the same amount of unknowns. With the same amount of unknowns. And so what we're going to be studying, maybe you did last year, we're going to be studying these the ways to solve these equations. So let me give you your first problem. The sum of two numbers is 13, and their difference is 3. What are the numbers? Let me repeat myself. The sum of two numbers is 13, and their difference is 3. What are the numbers? Okay, let's write that down. So, the sum of two numbers is 13, and their difference is 3. What are the numbers? What are the? I want you to think about that. Put this video on pause for a second, and put the video on pause and figure it out. Okay, now we're back. What do you think? What do you guys think? Well, you're going to have a couple of rules. The first thing we're going to do is, here's how I'm going to solve this. Take a picture of this. Do you see that? Take a picture. Take a picture. Take a picture. Good. First thing I'm going to do, and I'm going to ask you, if you were in class, I would ask you to cut that out, use the glue sticks, and glue it in your notebook. So what was the first thing? The let statement. The let statement is simply calling my unknowns by the variable. So I'm going to let x be my first number, and I'm going to let y be my second number. Okay, what was the second thing? Write a system of equations. If I have two unknowns, I better have two equations. So, there's two things. The sum of the two numbers is 13. Okay. X plus y equals 13. If I have, once again, two equations, I better have two unknowns. I better have two equations. The difference is 3. Good. So we have our system. Now, the next thing is we want to know how to solve it. Today, we're going to be using something called substitution. So the technique for solving is known as substitution. 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 And here's how it goes. When you have substitution, one of the equations you can easily solve for one of the variables, and then you're going to take that and plug it into the second equation, right? So it looks like this. So I'm going to look at this. What can I easily solve? So, yeah. So let's do a better example. Good. So the idea here is, and I'll get it for an example. The idea here is you're going to look at the first equation, you're going to look at the equation, you're saying, you know what? I'm going to solve. Good. Substitution. First problem. Sorry, we're going to use a new problem. Let's see if I can find it. Okay, so